So we made a very simple MIPS assembler that takes MIPS assembly language and converts it to machine code, the direct ones and zeros of it. It's fairly simple. We have it all on our GitHub wiki page, all the supported commands and all the helper functions that we used. Currently, a limitation to our program is that we mainly only support type R's, and I'll walk you through the program, and I'll explain why the decisions we made, why we made so. So the idea is that we have a main folder in our whole hierarchy of all folders. It's called assembler. We have assembler.asm. This is the main folder. Assembler.asm is an entry point. Here we give the input file. So input.asm is what's in there. This is what it's reading. You can also check up here. It's in the same directory. But what I'm trying to say is that this is the code that we support. So one thing that you're going to realize right away is that the .end is there. .end is just a simple directive that we use to make sure that this is the end of the file, to mark that's the end of the file, so that the way our file reader program knows. So all we do is we open the file from the input, then we open a file to write to, and here you can also specify in printfile.asm where your final output will go. So we'll use that here as the assembler. As far as that goes. And so again, then we want to go ahead and start parsing our statements as we read it. So we use something called input parser to do that. Input parser reads our files one by one, and then as we hit a space or something, we know that this is some type of operand or operation, so we process our operation. So all these commas are actually, when we're processing, converted to spaces. So that way, we're only looking for is space, and once it's a space, then we're going to go ahead and process and do something on that operand or operation. This way of processing, it's very open, even when we work with labels or anything. So then we go into the process operation method. Here, you're going to see all of our program, what it supports. Of course, we made some modifications to the program, so the GitHub is the most latest one to see what we support. This is going to be the README. Of course, everything is in a parallel array, so what we do is we go ahead and say we're looking for the add command, we search it against our array, and once we find it, we want to get all the arrays because we have the index are all parallel, right? So we send all of that data to the handle rtype method, which is located in the process rtype file. And in here, we have our opcodes, funccodes, and all this stores in the different spaces. So at different times, these come as we process our input character by character. And then we also have, of course, this is only for process operation. What about the operands? Well, we have a process operand function, and that function is actually called when process operation can't find an matching operation, it must be an operand. Therefore, go ahead and go to process operand and find the meaning here, and of course send it to handle rtype. And from here, we send it, we save it to memory with these spaces, and then once we need to print it, we print it. So that's how that works. Let's go ahead and give this a shot, and let's see it in action. So there is that tone. Of course, here is our little opcode, or the little code being printed, the machine code for our program. When you go here to our assembler and we go ahead to the output.txt, you're going to see that same code there present. And of course, our code, we've also tried implementing more than that. We also wanted to implement I and J instructions. This was the code for processing our labels. However, the problem was so that we wanted to create arrays. Again, the parallel array structure here, it only had supported 4 possible ones, except we were having an overwrite error, and so we were unable to add that functionality. However, the functionality does exist, and since you've seen the process rtype, it's very similar actually on how we would have done it in terms of process operand. So our code is very scalable, and I think that's the beauty of it. With a little bit more time, I'm sure we could have figured this out too. What I also wanted to show, was with some more complex types. So say I have a file, as I have here, in our sample, such as this. What would happen if I give it a J-type? Would it handle it gracefully? And our code actually does that very well. So not only does it also prints the console, so that's pretty good. Don't forget that .n. So of course here we have some labels. So it actually does detect the label. We just don't process it. Same thing for the jumps and the uh, all of this type of the BEQ and stuff. Is that it just doesn't process it. It only reads the code that it's really concerned with. And I think that's one thing that we managed to do, especially with the line by line processing. So again, found again, it found. It's gonna say, excuse me. Yeah. So separated, and then it separates everything. So if we did need to, our parser works fine. Label found, test. So again, all we need to do is send some processing to that, and save that address, and so it would work. And of course, add is our our supported one. So of course, and then so we're going to go to the output file again. We have our codes. I feel like you're seeing the same code over and over again. We can change this to anything, T3, T4, and we will definitely get two different files. This is just proof. Um, of course, that we are done with our program, and these are two different numbers. So as far as that goes, there's that. We have definitely made leaps in our program. There are some limitations, as I've said, with the INJ. It was very, learning how to parse all of this. We lost a team member along the way. So there's definitely, a couple things that we, fell back on. However, we finally made it through, and our program works. We are, we want you to see our documentation that we have on GitHub. Anyone is free to work with this code after this project is due. Thank you.